Good evening, class. This is week 7, I think, of basic stats. Hopefully, this finds you healthy and surviving the circumstances that we're in. I didn't get very many questions about, or I don't think I got any email questions about Chapter 7, so I'm assuming that went well. I'll be looking at the quizzes here in a little bit. But tonight we're going to do Chapter 8. In Chapter 8 and Chapter 9 kind of go together. They have their same concept. It's just the the value that we're going to look at. Tonight we'll talk about sample means. Next week we'll talk about what we call sample proportions. And then the focus will be on what we call confidence intervals. So a confidence interval is an estimator. That's all it does. We take values from a sample and we try to more or less predict or kind of give a range as to where we might think the population mean or next week the proportion would fall. So use as an estimator. You've seen the results of a confidence interval before, probably, if you ever looked at a poll and they said, oh, it's yes, 52%, plus or minus 3%. So tonight we'll talk about where that plus or minus comes from. Next week will be the percentages. This week it'll be values for the mean. So the first thing we gotta do is give a definition of what we call a point estimate, and for the parameter. So that parameter, remember, goes with the population. So the point estimate is just an estimation of that value. And when we collect sample data, the best estimate that we have is the sample mean this week, and next week the sample proportion. Excuse me. So that's where we start. So we start with this point estimate, and then we figure out a range, a certain distance on the right, and that same distance on the left away from that middle value, and that gives us this interval. It gives us a high and a low number. So next slide takes us to an applet. So I'm going to jump into my browser window here so you can see it. And so on this graphic, what you have in the middle, the green line is marked as mu. That would be the population mean. Now, when you're building a confidence interval, this is not something you know. If you knew what that population mean was, you wouldn't even build a confidence interval, because the purpose of building a confidence interval is to estimate that number. And if you already know it, there's no point in estimating it. So that is just so we can see whether or not our interval is going to capture it. So then the other things we have to have for our interval is we have to have a level of confidence. And that's usually determined by the problem. It will be determined by the problem I give you. A researcher would determine that value prior to starting their research. You need to have a sample size. In this case, it's just 20. You'll be given a sample size also. A lot of times, researchers will try to figure out what sample size they want. And they can do some math. We don't do that in this class, but you can do some math to say, hey, I want to be within 3 percentage points on either side. And then they know how big a sample they have to take in order to have that confidence interval that size. So when I take I'm going to take a confidence interval by hitting sample here. And when I hit it, all the excuse me, all the little gold dots down there, that's the sample of 20. Okay, the big black dot in the center of that line is the sample mean, and then that line stretches out the same on both sides, and that's the interval. So in this case, this confidence interval would have captured the mean, the population mean, if I'd known it. If I take another one, they captured it. The one thing that you'll notice is that each time I capture one, that it moves, and it's all based upon where the mean is. The sample means that black dot, the width of that interval, the length of that black line stays the same on all of those. So each time I sample, okay, that mean might be close to the actual mean. It might be far away. So far we've been They've all captured. Let's see if we can find one where it doesn't capture. I'm gonna keep going here. And this is how it goes sometimes. So there's one that just about, it was just on the bottom edge or the top edge of that one, so I didn't quite get it. So we're gonna keep going here. Eventually, we should find one that doesn't capture it. Or I'm gonna go and change all my numbers. Holy cow. This usually doesn't happen. I usually at least capture one. So I'm gonna reset this and try this again. So we'll do a group of 25. Okay, so now here's a group of 25 all at once. You can see the red one down here did not capture it. Okay, so when you build a confidence interval, you will not know whether yours captured or not, because that's not the purpose behind it. Whether it captures or not is how we interpret this 95%. Okay, so the interpretation of that, I think is the next slide, but basically what it means is if I did all confidence intervals possible for this population and this sample size, that 95 up there, the 95% tells me what percent of those intervals would capture the population mean. Okay, so it's about how many of all the confidence intervals that we could make for this situation that capture that. So here, I only made 25. There could be a million confidence intervals that you can make. There could be billions of confidence intervals you can make. Again, our purpose is not to know whether or not we captured it, is to find that confidence interval and have an estimate for it. When you say a level of 95%, there is, it gives you, it's a level of confidence, right? You feel confident that it's in there. It's going to be in the one that you have. It's not a measure of probability, it's a measure of confidence. So we don't ever want to say, hey, there's a 95% chance I caught it. No, there's a 95% chance that if I did all of them, 95% of them would capture the actual population mean. So we could sample another 25. You see that now there's another red one in there. There was no red one there. There's 4 red ones. So right now, if you look over here, I've done 100. We've hit it on 94 of them. So that's what a confidence interval is. Okay, and I know there's one question in the quiz where I ask you to interpret it, but for the most part, you're going to be building confidence intervals, doing the math part of things. So this is that repeated confidence interval process. So that's what I was modeling on that web page when I showed all those different confidence intervals popping up there, and sometimes you captured and sometimes you didn't. Just remember, when you build your confidence interval, you'll never know whether you captured or not, because you're not going to know the population mean. That's not the purpose behind that, is to do an estimate. So like in your project, you're going to create a confidence interval that's going to give you an estimate for where that population mean might fall for the data that you collected. And again, when you go back to these confidence intervals, each one's different. You don't know where the population mean is going to fall within your interval. It could be right in the middle, like one of these down here. It could be clear off on the right or the left, but you'll never know that when you build your confidence interval. And that's okay, because again, all we're doing is predicting. So this is a formula. So a couple things I'm going to point out. You'll notice that the only difference between these two parts is one's a minus and one's a plus. X bar, you should know what that is. That's the sample mean. In most situations, you'll be given the sample mean. This is sigma. So this would be your population standard deviation. Now, we talked about population a little bit, and normally you don't know your population standard deviation if you don't know your population mean, but sometimes they'll use past data and they'll say that's the population standard deviation. So tonight it's going to be real important that you know whether or not you know sigma or not. Okay, n is the square, n is your sample size again. And then Z is a number based upon that 95% confidence interval. So we'll, when we get to that part, we'll talk about how do you find that Z score. It's dependent upon that 95 confidence interval, or maybe a 99% confidence interval, or 90% confidence interval. So when we look at an example of when we find that, I'll go through several examples of different possibilities. So here's our first example. It wants us to make a 98% confidence interval for the population mean. So you notice we have the the mean, or the n. We have the mean and standard deviation. This is sigma, that's sample standard deviation. So I know I'm going to use a z-score. So the first thing I do is I need to figure out what my what z-score I'm going to have. So I'm going to take you back to I'll take you to Excel, and we're going to talk about 98%. So 98%. So I need to do I need a z-score. So to get that, I had to do a norm inverse. Now, if you remember norm inverse, you would put all the percent to the left of your value first, and then your mean and your standard deviation. Now, since this is a z-score, the mean is 0, the standard deviation is 1. But the number that we put in there first, so 98%, basically 98% would be in the middle of my normal distribution. So there'd be 1% below and 1% above. So I can do one of two things. I can either use the 1% below. Okay, that will give me a negative value, since it's the 1% on the left. So the z-score should be negative because I'm below the mean. Or I could do below 99. That would be, again, the percent left of the 1% at the top. And if I do this one, I get the exact same value, except it's positive. That tells me that the z-score would be 2.33, okay, for my confidence interval. So the formula was something like x plus z times sigma divided by the square root. It's not a very good way to type that. We'll just start typing in. So we had a mean of 78.2. I'm just going to do the plus one first. You can't do them both at the same time. We had a z-score of 2.33 times our standard deviation of 12 divided by the square root of 55. So that would be the upper value of my confidence interval, since we're using the plus sign. So it should give me a value bigger than 78.2, which it did. And if I copy that and paste it, that's probably the easiest way to do this, is actually use copy and paste, because all I have to do is change that plus to a minus. And that will give me the bottom value, something below 78.2. And so I get an interval from 74.4 up to 82, if you round it off. Okay, so it's an interval. So if I had a mean, if I was trying to give an estimate for the mean, I would say somewhere between those two numbers. Again, this wasn't in a context, so we kind of hard to write a conclusion statement about this, and we'll do that here shortly when we have some context to the question. But that's how you type that in. You have basically four numbers that you have to interchange, and the z-score is one that you're going to have to find, but we just found one. So I'm going to flip to I'm going to add another page in maybe add another sheet. Oops. Now I can add one. And I'm just going to make a z-score table. So z-score table. And so my first column, I'm going to put in the confidence interval, confidence level. So we just did 98%. and my z-score was 2.33. Now the reason I'm going to write this table out is because for z-scores, if I do a 98% confidence interval, it is going to be 2.33 for that z-score. Okay, in a little bit, we'll talk about a different distribution for a different situation, and that one you'd actually find that score every single time. But for our purposes here, we're doing a 98% confidence interval. Remember that we got that by doing a inverse norm or norm inverse, and we did something like 0.01 comma 0 comma 1. That's where that came from. So if I want to do like let's do a 99%. So 99%, I would do something like norm inverse. Now I have 1% split between the two ends, so that means I have a 0.5% on both sides. So if I do 0.005 comma 0 comma 1, that should give me the z-score 2.58, I believe. Okay, it's going to be the positive one. So I'm just going to change my math here. So we want to make sure. So I would do 2.58 would be sufficient for that one, and then we can do like 95%, which is the most common one. You would do something like norm inverse. Now remember, since we're finding these right now, you technically do not have to recalculate these for z-scores. This would be 1.96, and a 90% would be 90%. I always forget norm inverse. I'll do the top end 0.095 or 0.95 comma 0 comma 1. So that's not a 95% confidence interval. That is a 90. There's 5% on the top and the bottom in between those 2 points. So 1.64. Now you got a list of different confidence levels that you can use when you're building those confidence intervals. All right, so next example. So we're dealing with salaries of community college instructors. We've got a standard deviation. So it's normal historically. So that's our population standard deviation of 3,500. We have a sample size of 33. We have a mean, and we have a 95% confidence interval. So when I go into Excel and I want to build this confidence interval, let's write out the things that we know. So we know n is 33. We know the mean is 53,128. We know that the standard deviation, I'm going to call it sigma, not to confuse things later, is 3,500. And we have a 90 confidence level is 95%. So 95%, if I flip over to my sheet here, 1.96 is my z-score. So I'm just going to make a note, z equals 1.96. And now I can put my pieces in. So I'm going to start with my mean. I'll do the plus one again first. Then I'll take my z-score times my standard deviation divided by the square root of my sample size. Again, that gives me the upper value of my interval. And then I'm going to change that to minus. So give me my lower one. So now I have an interval from 100 or interval 51,934 up to 54,322. Okay, so now let's write a statement here about these these two values. So I'm going to grab my text here. I'll have to retype it. Let's type out a statement about our confidence interval. So generally, this is how it goes. We are, in this case, 95% confident that the interval from blank to up, or from 51,934 up to captures the true population mean salary for community college math instructors. So that's just a general statement. This is one that you can make for in your project. You should make something similar to this. I'm going to highlight the things that are things that you would change. So you would change the percent if it's different. You would change your interval if it's different. And then you would change the context that the mean is from. So all the things in yellow would be things that you would change when you write that statement. I do not ask you to write that statement on the quiz, but I do ask you to write a statement like this in your project. So you will need to have note of that. But then that's basically what it says. It doesn't say, hey, there's a 95% chance that it captures it. No, we are 95% confident that that interval captures the true population mean. Okay, so we have an estimate of what the population mean salaries of math instructors, college math instructors might have. All right, so let's look at another example. Oops, and I just closed my PowerPoint, so we're going to bring that back up. Sorry about that. So again, we have skimming through, we have a sample of 100. One-way distance, we have 10.22 miles. Estimate the mean one-way distance commuted by all commuting students. The point estimate, 95% confidence interval, and you say use sigma is 6. So we have values again, just like we did last time. So now you have this community college that's building a confidence interval for how far students might live. So why would you build one of these? Well, maybe they're trying to get an idea of how far out should they advertise for their community college. If all your students are within, maybe 15 miles, then I don't need to go much further than that, maybe to see whether or not, or to advertise for the community college. So just like the last example, let's write out what we know. We have n is 100. We had a mean, all right, mean this time, 10.22. We had a sigma of 6, 95% again, I think. Which gives us a z-score of 1.96. Again, I don't have to recalculate that. It's the z-score. Okay, and we'll jump from z-scores here shortly so you can see how that changes. So I'm going to start with my mean plus my z-score times my sigma divided by the square root of n. So again, this will give us something bigger than 10. And the same thing, we'll come down here, we'll throw the minus sign in there. Now we have interval. So we are 95% confident that the interval from 9.0 to 11.4 miles captures the true population mean one-way distance commuted by all commuting students at the community college. So again, it's an interval. So intervals will look a couple different ways on your quiz. Think a couple different ways. I'm gonna real quick look at the quiz just to make sure I see the values. One of the things I will post later tonight is I had a student that missed this class last year, and so I wrote up a bunch of notes, and they're handwritten. I will scan them and I'll put them up there so you can kind of see them. So intervals typically will be written. Some will just have the word two in between, but sometimes you'll see maybe some square brackets. You'll see me do this. And that would be another way you would see that interval being shown. All righty. So examples where you're using or sigma. And so that's the key from here on out. Do you know the population standard deviation or not? Now, generally, you don't know that. I do throw a few in on a quiz just to make sure that you're paying attention to those things. But generally, we don't know sigma. Okay, so again, if I know the sigma, I probably know the population mean. So it kind of defeats the purpose of doing a confidence interval. So assume you had the student standard deviation, or not students, but the sample standard deviation, S. I'm pretty clear within the problems as to whether you do or not. Sometimes though, it comes with the structure of the sentence. If I say something like, hey, here's a sample of 30 students and they had a mean of 10 and a standard deviation of 6 on the last quiz, that's a sample standard deviation, even though I didn't say it's sample because of the sentence structure. I start off by talking about the sample and then I told you descriptive stats about that sample. Okay, so you got to kind of look for that one, but be prepared for it. So when we don't know sigma, okay, we cannot use z-scores. We're going to have to use a different distribution. This one's called the student's t distribution. So let's talk about some characteristics. So the first thing is it's symmetric, just like the standard normal distribution. The mean is 0. Now the sample size gives you different distributions. So the larger that sample size, the bigger the degrees of freedom, because the degrees of freedom is literally just taking your sample size and subtracting 1 from it. But that's a number you need to have. And the bigger that number gets, the closer the distribution gets to the normal distribution. Okay, it's bell-shaped. It just has the tails are a little bit thicker. And as the degrees of freedom increases, that's the one I just said here a minute ago, it approaches the normal distribution. So those are characteristics, and you know me, I like to have questions on your quiz about the characteristics of the different distributions. So just be prepared. You can jump back into the video and look at this slide. There's lots of ways to answer that question pretty easily. So here's an example of you've got 3 different graphs there. You can see that we have the normal one in the purple. The blue has the degrees of freedom of 5. The black is degrees of freedom of 3. So you'll notice that the peak drops, gets a little wider at the tails get a little thicker as the degrees of freedom goes down. So if I got to a degrees of freedom of 150, it would look almost just like the normal one. For t distributions, the only function that we have to be able to run is the t inverse. And we'll jump in here in a minute and we'll do the t inverse when we do our first confidence interval using the t distribution. The nice thing about the confidence interval part is it's not any different. The only thing that you are changing within that is first you're changing, instead of a z-score, you're going to use a t-score. So we'll do a t inverse to get that. And then the standard deviation is not sigma, it's S. But in terms of the mathematics, it's all done the same. Once you have your t-score and you know those other 3 numbers, the calculations are the same, just like we did for the other confidence interval that we built. Okay, so when do I use a t? When I have the sample standard deviation, not the population standard deviation. So let's look at an example. So this could be an example where you're given the values. We've got what, 7 different values. These are just skeleton sizes, I think, shoulder heights. We have a mean, we have a sample standard deviation. So normally I have the class go into Excel and calculate the mean and the standard deviation. I won't ask you to do that on any quiz or test. You'll be given those. But then I'm asked to find a 99% confidence interval. So let's go over into an Excel and we're going to look at the values that we have. So the first thing I had was an N with 7. I had a mean of 46.14. I had a sample standard deviation of 1.19. I got a 99% confidence level. And I know I'm using a t-score, because population standard deviation. Yeah, I guess about right. Deviation is unknown. I don't know sigma, so I have to get a t-score. So we're going to use T inverse. T inverse works this way. A T inverse, you're going to put the percent that's outside of the interval. So the interval is 99%. That means 99% would be in the middle of that interval. That means 1% is outside. So I'm going to write this a little bit different. Outside, percent outside, and then degrees of freedom. So in our case, that would be inverse. I need a t here, though. Inverse t. And then I'm going to put my percent outside, so 1%. And my degrees of freedom is 6. I do inverse t, or is it t inverse? It's t inverse. My high school software is inverse t. Oh, shoot. See if we can fix this here. T inverse. Apologize. T inverse. The rest of it's right. T inverse 0.01, comma 6. And that gives me a t-score. Now here's the thing. If I see another 99%, if the sample size is not 7, giving me degrees of freedom of 6, this number changes. For z-scores, that's not true, because z-scores, we would say there is one z-score distribution. T-scores have a family. So if I do a t inverse of 0.01 and change the number to 19, that would have a n of 20. The value is going to be different. If I change that value to 200, it's going to be different. Okay, so if you remember, if you go back and look at your z-score, 99% for around 99% was what, 2.58. So as my n gets bigger here, I get closer to 2.58. I'm getting closer and closer to it. So large sample sizes, you're going to see that. So there's a family of t inverses, and that's why you have to calculate it for every single problem that you do. So now we have a t-score. We have a mean. So we'll take our mean. We're going to add our t-score. Again, we use a t because we don't know the population standard deviation. All I know is the sample. Everything else gets typed in the same. It's just a matter of where does that value coming from. And you have to recognize that value. You have to recognize that it's a different situation, that you don't have your population standard deviation. You have your sample standard deviation. So when you get done, you really don't know. It's a confidence interval. If you just saw the confidence interval, you would know if it came from one with sigma or not. Your conclusion's still the same. I think my next slide writes out the conclusion statement here. So the archaeologist is 99% confident the interval from 44.5 to 47.8 contains the true, I would say, the true population mean, shoulder height of the new discovery, something of that nature. So the key on this lesson is you need to know whether you're using a T or a Z. So if you read through a question, you're like, oh man, I don't know if I'm supposed to use a T or a Z, then just shoot me an email and I'll walk you through it, how to lead yourself through that. So a couple things just to review, because I know it's going to come up on the quiz. Remember, everything after the plus or I say this is not review. This is new. I've left this one out, so I'm getting ahead of myself for next week. Anything after the plus or the minus, okay, it's the same thing. Z over sigma, sigma divided by the square root of n, or when you're looking at t times s divided by the square root of n. This part right here, okay, that I'm circling with my cursor, is called the margin of error. Okay, it's the thing that we will allow to go above and how far we're allowed to go below. So when they give you those polling numbers and say 52% with a margin of error of 3%, that margin of error is plus or minus that 52%. So their confidence interval would be 49 to 55%. Again, we'll do percents next week, but the process is very similar when we go about calculating those confidence intervals. Let's see, I think that was the end of my slides. The main thing is, again, if you're stuck, ask questions. I know this is a little bit different than being in class. It's kind of hard to ask questions now. You're not going to disturb me. Just know that I might not be next to my computer when you email me. So I do in the evenings. I will sit and I will try to answer as I have my email on and I'm answering questions while I'm doing other things. But please email me if you have questions. I know I've got a number of emails about the project. If I think most of you should be able to do the confidence interval part on your project now. You just want to get ahead of that. The class ends at the same normal times it always ends, even though we went online. In terms of online quiz, I will post the answers to question or unit 7 here. You'll probably see that before you see the video. Yeah, like I said, I hope everything's going well for everybody. If something's come up, please let me know. You've got to communicate with me. I don't know what everybody's situation is, so if you don't tell me, if you need a little extra time, let me know. Just know that we have only a few weeks left, and we got to make sure we're taking care of things. And you're gonna have to carve out some time to do that. So just communicate, and we'll keep this thing rolling. Next week, we don't have to do the whole. Oh, what is a confidence interval? It's really here's the change from chapter 8 to chapter 9, and we'll crank that out. I will post a review next week for chapters 5 through 8. So after next week is when we'll plan on taking that week 9, I think would be. We're going to take the test 5 through 8. You'll do a written part. I've done it. I've sent it home before, so it's not like you got open note, open book. But we're probably going to have to set a time limit on that one. You're going to you're probably going to, I want you to start thinking about that in a couple of weeks. You're going to have to email me and say, hey, I want that written test at this time on this date. and then I will email it, and you'll have a certain window that you have to have it back to me. Um, it's as simple as you take a picture with your phone and you submit those to me or email those to me, and that's how I grade it. It will be front and back like it always has been, or like for the first test. That won't change. But I'll have a review. I'll post that this week. You can start working through it if you want, and then you can start asking questions on that. Um, yeah. So again, let me know what's going on. If you got things you need to, if you're stuck on something, and don't be afraid. Again, don't be afraid to reach out. I'm here to get you through this course, and we'll get you through it. Have a good evening. And again, if you have questions, give me shoot me an email. Thanks.